Just a minute. I will adjust the screen slightly. Manageable now. Full screen should be visible. Up to here I can go. Almost borderline. 1 minute. Up to here, okay. Okay, now any problem? Little problem. 1 minute. Little. Enlarge it. Okay, 5. Just a minute. The setting is the problem here. 720. See if any problem is there. Okay. AB okay. This also okay. Slightly I have to move this side. 1 minute now. Slightly I have to come down. No, not possible. I have to slightly reduce it. Yes, now okay. Now most probably okay. Okay, perfectly okay now. Little down. Little up. Okay. Very good. Yeah, this mic I forgot to adjust it. Okay, I'll put it here today because yes. Tell me, is the voice fully clear? Is the voice clear? I further can't move the screen. Full question I can arrange there. Is the voice clear? Little fast. Okay. See. Just for information of others, this question first we solved. See, make a note. This is today's class number 25, correct? See, today is class number 25. Remember, class number 25. Then, in class number 23, I started this question. I explained each and everything on that day. Regarding how to form stiffness matrix, I wrote angles, calculation of AE, trigonometric part, how is the unknown decided, coordinate system, and almost I made the table ready. That's all. I found for each member angle theta, what is cos, what is sine, then cos square, sine square, and cos sine, and AE and L. That is first class. Then in class number 24, I continued it. See, what happened is, I will tell you, class number 23, I took coordinate like this. See, this is A. I will explain once again now, lastly. Coordinate 1, coordinate 2, coordinate 3. So, UC, VC, and UB. That's how I wrote earlier. See, in the class 23, I wrote what? Class 23, unknown matrix, I should write, okay, red color is not required, still to make clear, red is better. I wrote unknown matrix, see, UC, VC and UB. But in class number 25, I first considered member AB. When I consider member AB, you get what? U3 will come. So in the delta matrix, U3 means what? Coordinate 3 is what? UB. UB jump to the top slot. So, delta whatever you get is not in this order. It will be UB, then you got UC and VC. Somehow I was not happy. There is no rule. See, when you write, anyway you are making here, whatever you get in the equation, that is the order. But better it match with this order. So I changed to, I made this is coordinate 1, This is coordinate 2, this is coordinate 3. Yes or no? Remember, I changed the coordinate. Remember it? I changed the coordinate. Yes or no? You go through all these from earlier 2 classes. I changed the coordinate, yes. Then, what happened was, it was not my mistake. There was a calculation mistake. In the displacement matrix, some calculation mistake. Then, after you got the displacement matrix, I told class was about to end on that day because there was some problem there of overwriting. Then I told continue next time how to find member forces. But I told what displacement matrix you got, whether it is correct or not, I told I will check now itself. How? Something I wrote here. I told you, you don't bother. Something I wrote here. I told you, you never bother about that one. I told calculate a number. I told that number has to come. I can do once again. $55.5 minus, yes or no? I told that number has to come. That is my trick. My own trick it is. Not for you. 55.5 I told. That is actually final answer. See, final answer for member AB should be minus 55.5 kilonewton. Okay, don't worry about it now. This was my commitment. But you told answer is not tallying. Then I told some calculation mistake. But after I left the class, message came to me that it is tallying. Who told? After I finished the class, after I left the class, I got a message that it is tallying. Yes or no? It was too late by that time. I was told it is tallying. That means some mistake you made. Okay, no problem. See, from my side there was no mistake. Only thing is, in the first time I took order 1, 2, 3, that becomes little odd for me. There is no rule that this order should match with that order. Nothing to worry. Any order you do. But usually, for understanding what order you write here, it is better to get same order here. So that correctly, see, delta later equal to UCBCBB. Otherwise, here you write UCBCUB, there you get something else. Not something else. Interchanged. A become, where A is there, B will go. Where B is there, A will go. Answer will come correctly. Then I told I don't like it. Okay, then anyway, finally, displacement, there was a mistake from your side. Calculation mistake. So, answer was not telling. Then you told later, after the class is over, you told, answer is telling. Yes or no? After the class over, you told me. After I closed the class, in the group you told me, answer is telling. Okay, no problem. So I decided, better settle the matter once again. Because this is the master question. Once a question is over, repeated questions I will record and give to save the time. There is no time also now. Repeatedly I will not take the same thing. So I better thought, start fresh. Remember, even though we start fresh now, previous 2 classes are important for studying. I told so many things there you have to go through. But when you make final fair copy, make today's fair copy. Clear? Make today's fair copy. Today no mistake. Make today's fair copy. Clear? Today's fair copy you conclude. Clear or not? Okay, I will start the question now. It won't take much time because everything is told already. Okay, now, see, the question given was, see correctly, I will start fresh now. As if today is the first class. Okay, done. As if today is the first class. See, question given was like this. One hinge, one roller. Some inclined load given here, one horizontal load given here. And this length given, this length given, this height given. For each member, area given, area given, area given, E given. See, first step, do not see finite element method. Go to trigonometry and get this length, this length, this length. I wrote the answer here. This length came 6.7082. This length came 5 meter. This length is given as 10 meter. Then, whatever A they told and E also given, multiply A in meter square, E in kilonewton per meter square will cancel. Like beam you write EI, in pin jointed frame you write AE. Solving unit is kilonewton and meter. See, our solving unit is kilonewton and meter. So get AE in kilonewton meter. That is, meter will cancel kilonewton. And we got the answer. This member 400 10 to the power 3 kilonewton. This member 320 10 to the power 3 kilonewton. This member 600 10 to the power 3 kilonewton. These all you refer class number 23, first class. Okay. Then also that inclined load is resolved into two components, vertical and horizontal. See, entered here. This is the entry, final entry. Now you solve this question or now continue as if this is the given question. Okay, start. One note I wrote. In pin jointed frame, see, in beams, displacements are horizontal displacement is not considered, vertical displacement. See, this also I told so many times repeatedly. In beams, when you take bending, where EI considered, see, vertical displacement and theta are the unknowns. But in pin jointed frames, theta is not unknown. Here, if you get any theta, it is not your radian theta. It is the high school theta. So that theta we got here, trigonometry. So here unknowns are only for pin joint frame, only what? Only horizontal displacement and vertical displacement, U and V. Theta will never come for unknown here. Okay, start. One note, hinge cannot move. U, V both are 0. Roller can move horizontally. So vertically cannot move. For roller, vertically 0, horizontally displacement is there because vertically reaction will come. Where reaction comes, displacement is not there. You see my SFD BMD introduction class. I told this very clearly why reaction comes. Okay, now, lastly, C. C is unsupported point. Unsupported point can move horizontally and also vertically. Actually, some pins you are right here. Pins. Pin basically to understand. This is a joint pin. So unknowns are horizontal displacement at B, horizontal displacement at C, and vertical displacement at C. These are the unknowns. Now arrange in order. First time I wrote, see, this one, 1, 2, 3, this way. Then because of the interchanging of table, I changed it. No, I will once again go back now. Make a note. When you start displacement matrix delta, you do one thing. Which point more unknown is there? First consider that joint. Tell me. Here, which joint more unknown is there? Make a note. This is not told earlier. This is not told earlier. Fresh. Which joint has more unknown? Consider that first. Which joint? Tell me. Which joint has more unknown? C. So first do one thing. Come to C. When you come to C, see at C, U and V both are there. Remember, if you always order is first U, then V. First horizontal, then vertical. So horizontal at U is 1. Vertical at C, horizontal at C is 1. See, that's why it is called what? Vertical at 2 is V over. Then lastly, horizontal at B is 3. Oh, I forgot right. Therefore, I write here now. One space problem is there. I forgot right here. Okay. Therefore, for this question, I can use here. Delta matrix equal to Which one? Tell me. In the same order. UC, VC and UB. Coordinate 1, coordinate 2, coordinate 3, U right side, V upward, U right side. This is the delta matrix. Okay, now start. Now you require first statement, element stiffness matrix. This I will not tell. Anyway, briefly, it is IJ. When you call IJ, very, very important. You should consider the joint I for reference. See, if I call the member AC, measurement of angle should be at A. If you consider the joint at C, if I call CA, measurement should be at C. When you call IJ, angle should be measured at I. Remember, if I call JI or if I call PQ, angle should be measured at the starting point. Okay. This is same. AE by L into lambda square, lambda mu, mu square, diagonally transfer that side, transfer this side, sign change, UV. This is already told many times. So, refer the earlier class. Okay, over. Refer the earlier class. Refer. Start. Now, first select the joint. If you remember last time, first we selected joint A. Tell yes or no. First we selected joint A. Tell yes or no. Tell first. First we selected joint A. Tell me yes or no. Yes, but what happens is, it is better to change that approach. I decided later. You select that joint where unknowns are maximum. Tell the answer. Which joint? Any joint will do. Select the joint. First you select the joint. This is the revision I am giving. That is easy approach. Now onwards, stick to same procedure. First select a joint where unknowns are more. Which joint? Tell me. Where unknowns are more. Which joint? Change it now. If you do like last time, answer will come. C. So I first consider C. See now, when you consider C, remember now, starting point is C. Member should be called CA and CB. Okay. Now further. See here. First from C, you mark positive X. Then mark the angle each member makes with positive X in anti-clockwise. So this member, this is the angle. Tell this angle. Tell the angle here. See, this is 26.565. See, you know, this angle is 26.565. So tell me, what is this angle? First, what is this angle? First answer. This is, you can see here, 26.565. What is this angle? First. That angle. First. Don't waste time. We want angle made by the member with the positive X. Always see, with this line, this way we want the angle. 206.565. It is 206.565. Oh, I printed long there. Okay. But I calculated correctly. 565. 565 is this angle. Next member is here. Do not write this angle. Come round and write this angle. Tell the answer. One full round this way. See, this is 36.87. So this is 323.13 degrees. Correct or not? This is clear? Fast. This is clear? This is clear. Fast comment required. Is this clear? Step. Okay, now make a note. When I come to C, CA member is over, CB member is over. So be careful now to make a note here. See, CA is over, CB is over. Come to next joint. After C, next unknown is at B. Consider joint B. When you consider a joint, second time joint, those members which are already considered in the earlier joint should not be considered. See, when you come to B, One member is BA, other is BC. See, this BC is not to be considered. Why? Because CB is already there. So at B, only BA. Positive X is here. See, you require this angle. It is 180 degrees. Clear? Why 180? See, we want angle from positive X. Full this way, 180 degrees. Okay, clear. Okay, now, immediately prepare a table. Now do one thing. Today, check the table correctly. I do not want a mistake and do the question once again tomorrow. Okay. Start. Joint. See, joint C. Main joint C. Name the members. One of them is CA, other is CB. Okay, no problem. Any order. CA and CB. Now, when you take CA, angle is 206.6565. When you consider CB, angle is 323.13. Calculate cos, square it right here. Calculate sine, square it right here. Calculate sine into cos right here. Correct answer? 0.8, 0.4. This is correct. Cos of, check the answer. Cos 206.565. Correct? Just verify. I do not want any mistake. I think it is correct most probably. Cos 206.65 is correct answer. Okay. Now, for this member, angle is 323.13. Cos 0.8. Cos square here. Sine minus 0.6. Sine square here. Cos sine here. And also enter AE for the member and length. AE in kilonewton, length in meter. Now, joint C is over. Put a double line. Double line means joint over. Now, last joint is B. See, you need not go to A because both the members are already over. B. Member is BA. Angle 180. Cos square. Sine square. Cos sine. Enter everything. Is the table fully clear? Tell the answer. The revised table for today. Fully clear? Fast. Is the table fully clear? Okay. Now, start. First, don't see here now. See, start from here. I'll tell you root. First, consider CA. When we consider CA, AE is 410 to the power 3. Length is 6.7082 into cos square 0.8. Then cos sine or lambda square 0.8. Lambda mu 0.4. Lambda mu square 0.2. Enter this much. And order, since you call CA, UCVC, UAVA. Okay, now, very simple. Diagonally transfer as it is without any change of sign. Happily transfer diagonally. And this way transfer with change of sign. Over. Hey, come here. If anything is wrong, let me know now itself. Not later. Over. CA member over. Go to CB member. CB means, see, UCVC, UBVB. Cos square. How much? 0.64. Cos lambda mu minus 0.48. Mu square 0.36. This is lambda square, lambda mu, mu square. Diagonally transfer as it is. 0.64 minus 0.48. No, whatever is there, transfer as it is. Then left to right, right to left, transfer, change the sign. Minus 0.64 plus 0.48y, minus is there. Plus 0.48 minus 0.36. Come here. Minus 0.64. Come. Plus 0.48. Come. 0.48 minus 0.36. Okay. Lastly, member is after this member, space problem, I am adjusting next to this member. There is no space because this I want for equilibrium. Okay, now start. Lastly, K for BA. Since it is BA, UBVB, UAVA. Cos square 1. cos lambda square 1, lambda mu 0 0, mu square 0. Now hey, come this side, come as it is, go that side, minus 1 0 0 0, you come this side, 0 0 0. Perfectly clear, without any doubt? Tell me. Perfectly clear, without any doubt? This is all I can remove now. Perfectly clear, without any doubt? Okay, now no space here, then write equilibrium equation is, there is no space there, I am writing here, P matrix, force matrix equal to stiffness matrix delta into delta matrix. Okay, now this is with respect to global, this is I am telling earlier, so this is your P matrix here, this full is your K delta matrix, this is your delta matrix. Start. You what order you have to write? See here, Ilinda. Same order you have to maintain. Sorry. Oh, I think it interchanged. Oh, first see again problem. What happened is I wrote UB first. No. See, gone. Sometimes see in a little hurry it happens. What to do? I don't know what to do now. UCVC comes there. Okay. Nothing to worry. I will change it. Not a problem. See, when you write, see something, human nature, such mistakes, not a mistake. See, when you write stiffness matrix, do one thing. See, 10 to the power 3, 10 to the power 3, 10 to the power 3, to save time, save space, put outside. Then, maintain the same order. UC, VC. UC is actually, remember now, later your UC is there. If UC is there, see, later remember, your UC is there. If it is there, leave more space. UC is there. Okay. UC is there. I'll write once again. UC is there. After UC, see, UC over VC. VC also is there. So, you need space. UC, VC over. UC, VC, UAVA. UAVA both are 0. See, UAVA both are 0. So, you don't require space here. UA 0, small space. VA also 0. Why wait space over? Lastly, UCVC, UAVA, UCVC, then UBVB. Oh, UB is there. So remember, UB is there. If it is there, more space required, UB. VB is not there. So VB, you don't require space. Okay, start. Then here also write what? Same order. Which one? UC, more space. More space for UC. Then here VC, more space for VC. 10 to the power 3 up to here only. Okay, this is there, this also is there. Okay, idu ide actually. Okay, then last write decoration. UC over VC over. Then UA is not there, 0. Don't wait space. 0 it is, not required space. Then VA also is 0. No space required for VA also. Why? Waste of space. Don't waste space. Space is precious. This is 0, this is also 0. Okay, then UB is there. UB is there, you need more space. UB is there. Correctly bring up to here. Can I tell you? Yes, okay. UB is there. Then, lastly, VB is not there. Neat, okay. No, UB is not there, no space required for that one. Illi, 0 over. So remember, this also, this is 0, this is 0, VB also 0, UA 0, VA 0, UB 0. Now, first, cut unwanted. VA line cut. UA, VA cut. VB cut to save the space. Then, VA, this also cut. Allu cut, illu cutte. Then, this also, this also cut. Cut. This also cut. Cut, full cut, don't worry. Cut. So now you require this number, UC with UC, this number, VC with UC, then this is symmetrical number. First, here you want UB with UC. See, UC with UC, UC with what? VC with UC, UB with UC. Then second round when you do first time, first number is not required. Second number, VC with VC here, VC with UB here. Last one, this also not required, symmetrical, UB with UB. Is the format, little ink problem is there. In a drawing sheet, can you neatly write with the neat arrangement so that crystal clear. Cutting, use red color. For cutting purpose, use red color. Tell me, crystal clear. Cutting purpose, use red color. No comment. Crystal clear means tell me. If crystal clear. Okay, now, remember direction, here see, UC is right side, then VC is upward, UA is right side, VA is upward, UB is right side, VB is upward. Okay, start. First straight. See, 10 to the power 3 is outside here. I use the blue color now because why? The black color is not writing. I use blue color. Okay, start. UC with UC, little fast. UC with UC, ಇದು VA. UC with UC is 0.8. 400 divided by 6.7082 into 0.8, not over. See, UC with UC over. Again you got UC with UC here, 0.64. What is the number? Plus 320 by 5. 320 by 5 into 0.64. Tell this number fast now. See, it will come correctly by 5. Tell this number. I will use red color and write it. Tell that number. No mistake now today. Today, absolutely no mistake. Time is there today. Up to 10:30, no problem for me. Don't make mistake actually. Correctly calculate. 88.66. Don't make mistake. Be very careful. Was this number there earlier? Tell me. Same number should be there earlier also. Check it. See, even though we interchanged here, your original first time when you did, same number should come. Okay. Then VC with UC. Not VC with UC. 0.4. That is 400 divided by 6.7082 into VC with UC into 0.4 and UC with VC with UC. VC with UC is minus 0.48 plus 320 by 5 into minus 0.48. Tell this answer correctly. Full number. Tell this number correctly. More accuracy. At least 4 numbers. Tell this number. Tell this number. Every number should tally. This number. See, this is 0.4. This is minus 0.48. Fast. If this is not tallying, what I will do is, I will go for recorded class. No, is the same number there? You should tell the answer if you verify the same number earlier. You should verify same number earlier. 6.868, little more accuracy. Little more accuracy. 4 decimals. Give me 4 decimals. See, I told you, give me 4 decimals, not third decimal. 6.868, give 4 decimal answer. Or that's all, only third decimal answer. No, you should give 4 decimal answer if it is existing. See, you do one thing. When you tell the answer, if it is third decimal, you tell 0 there. Then I will be knowing that you have done 4 decimal. Otherwise, doubt comes for me. You have skipped the last number. If it is 4 decimal is 0, you tell 0 only. 6.86 ನೋಡಿ ತಪ್ಪು ಮಾಡಿದ್ರಿ ನೀವು. 6 ಪಾಯಿಂಟ್ ಮೈನಸ್ ಪ್ಲಸ್ 6.8686 minus 6.8686. Okay. Here, UB with VC. ಎಲ್ಲಿದೆ? UB. There is no UB here. UB UB with what? VC. UB with what? UB. What number? Which number you are doing? This number. UB with UC. UB with UC. Oh, illide. Minus 0.64. Number is 320 by 5 into minus 0.64. Then, see, UB with UC. UB with UC. UB, there is no UB here. And here there is no UB. Here UB with UC over. Here UB with UC is not there. Answer. That's all. Number. Give me 4 decimals. It's bega. This number. Today there should be no mistake. Still remember, when the calculation part comes, mistake means your problem, not my problem. But it is frustrating, this number. Minus 40.96. Thank you. But tell me, was the same number there earlier also? 9600. Was same number there earlier also? Tell me. Confirm it. Earlier also, same numbers were there. It should be same. It can't change. Even if you change the order, number system cannot change. Earlier what you done is not wrong, but I made it more comfortable now. That's all. I made it more comfortable. Okay, start. This is symmetrical, not required. VC with VC. Correct body. VC with VC is 0.2. That is 400 by 6.7082 into 0.2, and then VC with VC. Here VC with VC minus. Here. See, it cannot be negative. See, same number with same number cannot be negative. Okay. ತಪ್ಪಾಯ್ತು ನೋಡಿ. ಇದು VC with VC 0.36 plus 320 by 5 into 0.36. Tell this number correctly. 4 decimals. Tell that number. We are almost closing now. See, first 2 days what you took, I finished it in only 45 minutes now. Number. Before you tell the number, you check your old matrix. 34 point, same number was there, no? Don't tell the number if it is not there earlier. 34.9657. 34.9657. Okay. Here, UB with VC. There is no UB here. UB with VC. This number. 320 10 to the power 3. 10 to the power 3 ಇಲ್ಲ. 320 by 5 into ಯಾರು ಬೇಕು ನಮಗೆ? UB with VC. UB with VC is 0.48. That's all. Anything here? Here not there. Tell the answer. There it is not there. Answer. Now only one more number required. Over question. Just one more number required. Question over. Only one. 30.72. Okay. 30.72. Now, symmetrical, last one. UB with UB. Yes, there. See, UB with UB is 0.64. 320 divided by how much? 5 into 0.64, and also, see here, UB with UB, 1 is there. 600 by 10 into 1 plus 600 by 10 into 1. Last number, over. Last number, over. Now remember, now if answer is not tallying, if any mistake is there, I will close the class and delete today's class. I will delete it. Why? It will hurt me. In my class, see, if technical mistake is there not hurting, I will stop my teaching. If a technical mistake is there, I will stop my teaching. But because of the see this beam problem, I am comfortable. I won't ask you this much. I look at the beam and tell the answer immediately. I don't require. Suppose these numbers are for beam, I can make out in seconds. But truss problem, E sin cos, problematic it is. It is a horrible. It is actually frustrating. So chance is always happens. Trusses, especially displacement, not finding force in the truss. There I got fluency. Their resolution is there. When the displacement comes for truss, in even structures also, I feel uncomfortable. Why? So many table, number, point, etc. One small mistake means gone case. Therefore, answer 100.96. Okay. 96. Now, lastly, force matrix. See, you see right side force at C. Yes, it is there. Minus 25. Why? At C, horizontal force is right side positive, left side is there. Then we see vertical force at C in upward direction. Oh, downward is there. Minus 43.3. Lastly, usually this force they don't give. Suppose exam, they give only one force, other is 0. That's all. Lastly, horizontal force at B to right side. Yes, right side. Plus 10. Therefore, I will come to here now. I will come here. Equilibrium equation reduces to. Okay. I will write here now. Reduces to 43.3 minus 10. 25. Seeing, not seeing properly. Minus 25 minus 43.3 plus 10 equal to 10 to the power 3 times number. 88.66. Come here. Minus 6.8686. I will remove this one, correct? Okay, this I will remove. I can remove this one by not required. Then minus 40.96 times here. Next, 34.9657. Then 30.72. Last number here, 100.96. Symmetrical right here, same. Minus 6.8686. Hey, come here. Minus 40.96. You come here. Plus 30.72 times what? UC, VC and UB. See, correctly it is order number 1, 2, 3. See the advantage now? Correctly 1, 2, 3. Therefore, I will write here now, space problem, I will write here. Therefore, solving, we get your delta matrix equal to Y delta matrix. It is UC, VC and UB. UC is coordinate 1, VC is coordinate 2, UB is coordinate 3. This is right side, this is upward, this is right side, equal to, you get the 3 numbers here. These 3 numbers should correctly come same as your confirmed number last time. Check it. Coming. What? Correct, tell me. What number last time by WhatsApp you have sent me? Same number should come, but order will change. Order will change because last time I took this as 1. So last time your UB was the last, your UB was first. Now your UB is the last. But now you solve in calculator. Solve in calculator and tell this answer. Fast. Solve and tell these values. Fast. Then I will go to the final part. If it tallies, I will apply the check right now only. Answer. I will apply the check. If the check passes, I will go to conclusion part. Answer. I will take a small break at that time. Why? Non-stop talking, but not now. You give the answer, I will apply my check. When I apply my check, when the answer tallies, I will remove all this and go to the final part. Answer. Solve using calculator. What UB, UC, VC we got last time, same answer has to come now also. Number may be interchanged. This much time. Not coming means I have to delete the class, I will stop the class and go for recording. Recording means what? I can write, I have no disturbance. I can take my own time then. Is it same as last time? What you told last time, this number. Order is, see, what I am telling now, it will have, last time answer should be same. But one thing, order will be changing. If the order changes, what you gave today, you should have got last time. No, what you told today, you see, that you see would be the middle number last time. See, what you told today now, first number should be middle number last time. Telling, okay. Sorry, one thing forgotten. It is 10 to the power minus 3 times. Be careful. Why 10 to the power minus 3? Because when you solve here, this will go that side. 10 to the power minus 3 times, your answer is minus 0.1528 so much accuracy not required, minus 1.775603, last one, plus 0.57733 is the answer. Now take your calculator. I will write something for checking purpose now. Okay, this I will remove. You don't bother. I will check the member. Which member now? Last time I checked for AB. Okay, AB I checked, I think. No problem, don't bother. I checked for AB last time. Shall I check for BC? Still better. If I check for BC, it's still better. Why? Okay, I will tell you now. Don't worry. I will check it for BC. You never bother. What I tell you, calculate. CB. A. Just what? See, this is purely my own concept. Or I will explain this one. You never bother. 320 10 to the power 320 divided by 5 into 10 to the power 3 times, you remember that? CB, lambda is minus 0.8, then mu minus 0.64, minus 6 mu is to minus 0.6. ಯಾವ ನಂಬರ್ ಇದೆ ಕರೆಕ್ಟ್ minus 0.6 no lambda is ಯಾವ ನಂಬರ್ CB is 0.8 minus 0.6 CB angle is this one sign correct minus 0.6 plus 0.6 then plus 0.8 you never bother. I will explain this one for you. I want checking now into 10 to the power minus 3. So it will cancel. Anyway, why should I waste space? 10 to the power 3 will cancel. Times, multiply. Which one? Yav member ಮಾಡ್ತಾರೋ ನಾನು? CB member. I remember writing CB. UC ಎಲ್ಲಿದೆ? UC. Minus 0.15, 281 ಸಾಕ್ಬಿಡಿ. After UC, VC. Where is VC there? VC is here. Minus 1.7756. Then UC, VC. ಯಾವ ಮೆಂಬರ್ ಯಾವುದು? ಮೆಂಬರ್ CB. Member CB, where here? UC, VC, UB. The UB is plus 0.57733 and 0. Now tell me, see. Into this number, you tell me what number you got. Change, have I changed the sign? Yes. You tell me what number you got. I will do one thing. I will take my calculator and tell you what number should come. This is none of your business. This is my own personal knowledge. You never bother what I am doing. Some will tell, sir, this much, 3 classes, how you get in one line only? No, don't bother. ಏನೋ ಬರ್ತಾ ಇದೆ. This is 3, this is 4. I got my answer. Where is the? I got my answer. I will write here. I will write the paper. I got what is the answer I want. Tell the answer fast. I already got my answer. See, now I will do one thing. I will show you what answer I got. I wrote it without seeing your answer. Shall I open? Is the number for you visible in the display? Tell me. What I am showing in the here, is it visible for you? ಇದು ಹೋಗೋದಿಲ್ಲ ಮುಂದೆ. Can you see the number what I wrote here? Tell me. Can you see the number what I wrote here? Yes. Tell me. Did you get the same answer or different answer? That is, my paper I wrote minus 30.8. Oh, you also got minus 30.8. Congratulations for you. Why? Because you did correct calculation. Don't congratulate me. Why? There is nothing here. I don't require any congratulations. So, congratulations, answer tally. Okay, done. Now leave it. Now, before I proceed further, one small information for you. See, up to here, now this step you never bother. You never bother this step. I will explain to you. This is not the way to solve. Okay. This is, I am satisfied that result is correct. Okay, now, correctly observe what to do. Where is the paper? One nimisha. Now, correctly observe how to continue further. Okay. Sometime in examination, they can give a question of this type and they may not ask you to find force in the member. The question will be only for the given pin jointed frame, find the displacements. That's all. So therefore, I will do one thing now. I will remove all this. Not required now. See, now make a note. Suppose we see, actually you got the answer there. That is presentation. Suppose in question they asked, find displacement. If they are not asking, this step is not required. Then what delta we got Present it properly. Present it properly. Otherwise not required. Your delta is here. Otherwise delta is here. See, UC, VC, UB is there. How to present it? See, how to present it is, remember, problem is solved in kilonewton and meter. Therefore, all linear displacement will be in meter. So answer. Therefore, see, start. First one. Which one? UC. Horizontal displacement of joint C. That is called UC equal to, tell the answer. Don't write minus now. Now don't write minus. No minus sign. Remove the minus sign. 0.1528125 into outside number 10 to the power minus 3 meter. That much, tell me. We took right side positive, negative came. That much right side or left side? Answer. That much displacement, right side or left side? Tell the answer. That much displacement is to right side or left side? Because you see sign is right side positive. That much displacement which side? Right side or left side? Answer. Left side. If you got negative, right, left side. In case you got positive, right side. You can write. That is, see, if for a person going in the road, if you tell 0.1528125 10 to the power minus 3 meter means, he won't understand. Multiply by 1000. How much? Oh, this will cancel. 0.1528125 millimeter. Okay, now he will tell, oh, understood. Same way right here. Vertical displacement of joint C, that is VC equal to, only if they want, where is the answer? 1.775603 10 to the power minus 3 meter. You took upward positive, answer came negative, that much downward. Then write, that is, multiply by 1000, 1.7756 millimeter. Lastly, horizontal displacement of joint B, that is UB. How joint B will move? Equal to plus came 0.57733 10 to the power minus 3 meter to the right side only. That is, you can write how much? 0.55733 millimeter. Next question onwards, I will not tell this one. This is required only in hypothesis examination. If they ask you what are the displacement. Otherwise, as soon as you get delta, go to next step. This much. Fully clear? If it is fully clear, I will go to conclude the question now. But little theory is there. Full clear? Okay. Now, all I will remove. I do not want angle. I do not want stiffness matrix. Nothing I want now. Now I want only, see, now I want only, nothing required. I want only delta matrix. Other than that one, nothing I require. Last step, concluding part of the question. Because you make a note, usually such questions, examination, what they will ask is, what are the forces, axial forces in the members, compression or tension? But I will tell you one thing now. See, now, further continuation, that is, after getting what? After getting delta matrix equal to UBL, which one first? UC, VC and UB, remember 1, 2, 3 equal to, you got the answer there. How you got answer? It came in equal to, this is what direction? Right side, upward, right side, equal to 10 to the power minus 3 into those three numbers. Okay, now further continuation. I will tell. I talk non-stop for 1 hour, high-pitched voice. Shall I take small break? No problem. That 5 minutes break for me because non-stop I talked. So little break means I feel relaxed. My health is okay now, no problem. Shall I take some 5 minutes break? Okay. You also relax for 5 minutes. Relax for 5 minutes. I'll come. Don't leave. Today I want to fully complete the question and want to give you homework for you also. Because once this question is over, further next class I am going to shape function solve. I am leaving this one. Further questions I will give you by recorded. Okay? Because time is not there. Further questions I will give recorded version. I can give problem with the answer within no time. But what happens is, if I for practicing purpose, recorded means I will write, I will describe everything so that it will help you actually. Okay. Just 5 minutes break. So that I will relax for 5 minutes. Don't leave the class. Be ready. Sometime when I take the break and come back, someone will vanish. Don't do that one. Okay, I'm back. Just 1 minute. Starting now. Okay. I'll go for concluding part now. Before going to concluding part, see, this is called risk. No risk actually involved. This frame actually very simple. This is 55.5. This one just you got how much answer? I only got it. In the paper I have shown you. I have thrown the paper somewhere. I don't know where I have thrown the paper. 30.6. 30.6. And this force in the member will be, let me check it now only, so that give the answer first and then solve. Not telling I will be in trouble. I am ready to be in trouble. ಇಪ್ಪತ್ತೈದು 10 25 15. This is risk actually. This risk I should not take. 34.64. Okay. See the arrow mark also. This I will tell you later. This is the final answer. I am sure this is my own trick. You never bother. This is the last step. We're taking the risk. Okay. See, now I will tell only once. Okay. Next time onwards, I will not do cut like that. Next time onwards, you have to do it. Shall I tell? Only once I will tell principle now. Principle I will tell. I can give formula directly, but still I will tell you principle. Agreed? Only once. Then it will not take much time. Agreed means tell me. Go through the principle again and again. Agreed? Okay. See. For members, now consider individual members. Individual members. Tell me. From structural design point of view, tell what you want. Suppose there is a roof truss. You want to design a roof truss or a bridge truss. Structural design point of view. Tell me what you want. See, you know this girder, that girder, roof trusses, bridge trusses, railway bridges, all. Structural design point of view, what you want? Tell me. What you want from structural design point of view. Exam point of view, I will tell you here. In beams, you require shear force and bending moment. Same way. For see, I am about tell the answer. Okay. I have told and stopped. You want axial force in the member. We want axial force in the member. And when you want axial force, you should know what? Whether it is compression or tension. Why? Then, if it is steel structure, design of a compression member or design of tension member. Agreed? Once you know the axial force, then you can go for design of the member based on the axial force, tension member. Design strength PD equal to what? PD equal to, formula is there, strength based on rupture, strength based on yielding, strength based on block shear. If it is compression, strength based on buckling, FCD into area, slenderness ratio, all will come. So, Any structural designer, he want axial force, compression or tension. But exam point of view, but subject point of view, three things. First, we want axial deformation. Tell me what? That is whether member contracts or tension first. I don't think. Actually, tension is the positive. Tension or compression. Okay. Tension means member elongates or contracts. Second one, what is the strain in the member? Strain, if you want. And lastly, what is the stress in the member? Lastly, most important, what is the axial force? Axial force. Clear? Lastly, what is the axial force? Say P. Strain you call epsilon. Change in member, don't call delta. Capital delta stands for what? Displacement. So, small delta. See, capital delta is a joint displacement. Call small delta. And strain epsilon. Elongation what? Small delta. Stress sigma. Clear? Clear or not? These are all required. I will explain everything concept now. How finite element method will calculate it. Correct or not? Clear or not? Clear. Okay. Now, see correctly one important aspect now. Your member, see, this is the principle I am telling. Principle. Member Ij is here. Our sign is tension positive or compression positive. Every software, remember one problem. In ETAPS, it is tension positive. But in STAD Pro, it is compression positive. But usually, universally, I will stick to one of them now. Tell the positive. See, ETAPS takes tension positive. STAD Pro considers compression positive because reason ETAP goes by basic concept, finite element method. STAD Pro, they decided usually columns are in compression. Why should I give minus sign for that one? So STAD Pro decided compression positive. They changed the sign. Universally, what is positive? Tell me. Usually, universally, they take tension positive. Tension positive. See now. Now, see, J. If the joint J moves right side by Uj and goes up by Vj, and joint I moves right by Ui, goes up by Vi, tell me, due to Uj, tell what is the elongation of this member. Tell me. This is Ij. See now. Now what will happen is, because of this one, your J will go to a new place called J dash. I will go to a new place called I dash. Tell me, what is this one? It is Uj into cos theta plus Vj into sin theta. See, it is component here, it is component here. If Uj is here, this is theta. This along the member movement is Uj into cos theta, resolution Vj into sin theta. Same way, this I to I dash movement is Ui into cos theta plus Vi into sin theta. Clear? If it goes this way, it will move this way by cos. If it goes this way, it will move by sin. Clear or not? First, tell me. If it is clear, I will go to the next step. This is simple to understand. Along the member, resolve it. Clear? Okay. Now, tell me. Suppose a member is here. This moves by 6. This moves by 4. Tell me, axial deformation. Tell me. Axial deformation. This goes by 6. This goes by 4. Tell me. Remember, starting point is here. I is the starting point. If J goes right side, this way by 6. This goes by 4. Tell me axial deformation. This is very important. Tell me axial deformation. Tell me what is the, I will give practical example for you also. By chance, 1 minute, this is not moving, it is fixed. No, 0, here 0. If it goes by 6, tell me elongation, how much? No, this is fixed. This goes elongation, how much? Elongation of member. How much elongation of member? Top one goes right by that along the 6. Bottom is fixed. Elongation is 6. Elongation is 6. Now, suppose this goes by 6 and this goes by 2. Tell the elongation. Then delta. Don't tell 6 plus 2. Be careful. Elongation is actually bad. Strain. Correct. It is 4. Whereas, suppose this goes by 6 and this goes by 2 here. Now tell me, if that goes that side by 6, this goes this side by 2. Answer. Answer. Top upper one goes along the member by 6 that side. Lower one comes this side by 2. Elongation. Fast. It is not 4. It is 8. It is 8. See here. It is 8. This will, see here. This member here. This moved by 6. This moved by 2. Here to here is 4. Clear or not? So, the elongation of member is how much this will move. What is that one? That is what? See, how much the top will move. Sorry. Elongation of member is this will move by what? See, answer is there. Uj into cos theta plus Vj into sin theta is this movement. You have to subtract this bottom one. Which one? Ui into what? Ui into cos theta plus Uj into sin theta. Sin theta. Or, if it is this way, negative will be there. That minus here. That is 6 minus of minus 6 minus 2 is 4. 6 minus of minus 2 is 8. Clear? Or I will give a, tell me, if the axial deformation is more, then strain equal to what? Change in length by original length. Stress equal to strain in, this is strain. Strain into Young's modulus. Force equal to stress into area, sigma into area, stress F sigma, stress C, strain epsilon equal to change in length by original length, stress sigma equal to strain into Young's modulus, force equal to P equal to stress into area. These all elementary strength of materials. Change in length by original length is strain, strain into Young's modulus is stress, stress into area equal to force. These all you are right. I put randomly. Why? This is actually not FEM, original. Clear? Clear. Okay. Now, I will give an example for you. Imagine in a road highway, one vehicle is going at a speed of 60 kilometers per hour. A vehicle from backside, or it goes at 80 kilometers per hour. See, one moving. From this side, another vehicle comes at 90 kilometers per hour speed. There will be impact. See, there is no place to overtake. This will try to overtake, suddenly it comes that side, so it will collide, accident. Tell me. Tell the net effect, danger effect. A vehicle is moving by 80, from backside, a vehicle with a speed of 90 will come and hit. Tell the severity of the accident first. Tell me the severity of the accident. How much? Is it a minor accident or a danger accident or worst accident? Tell me. A vehicle going forward, from behind, vehicle is already going on the road. From behind, with high speed, see, that is going at 80, this will hit at 90. Tell me, is it a somewhat light accident or no, this is the light accident. This is the light accident because it is already moving at 80. When this 90 will hit it, the impact effect is how much? Tell me. Impact effect. How much speed? Impact effect speed. If you hit from backside, tell me, it is not danger. It is a light accident. Tell me impact effect. How much impact effect? Goes by 80, hits by 90. Only 10. That is why it is what? This J, that one minus this one. See, I told you, that displacement minus this displacement is the net displacement. See, that displacement minus this is the straining action. Okay. Now, suppose a vehicle goes at 90 kilometers per hour and hits a what? Parked vehicle. A vehicle is parked in the road. That vehicle is not moving. It is parked, roadside parked. A truck. A car will come at 90 speed. Hit it. Tell me, light or severe? Tell me effect. You see in Kannada, ನಿಂತ ಲಾರಿಗೆ ಗುದ್ದಿದ ಬಸ್ಸು ಅಥವಾ ಮರಕ್ಕೆ ಗುದ್ದಿದ ಬಸ್ಸು. It is danger, worst case. Tell me, impact effect now. Impact effect. How much impact number? Impact severity number. Impact severity number. That is parked vehicle or a tree, roadside tree. Impact number 90. Now take another case. A vehicle is going at 90 speed here, opposite side a vehicle from 80 is coming. Now tell me impact effect. Is it light one or danger one or almost gone case or terrible? What? Light, danger or terrible or disastrous? What is one? ಮುಖಾಮುಖಿ ಡಿಕ್ಕಿ ಕನ್ನಡದಲ್ಲಿ ಆಮ್ನೆ ಸಾಮ್ನೆ ಡಿಕ್ಕಿ. ವಾಟ್ ಈಸ್ ಒನ್? Is it better or further worst? It is gone case. See, in a traffic, suppose due to some reason, suppose some problem is there, you apply the brake or some slipping is there. If you hit a vehicle from behind, effect is lesser. Your bumper will get cut and usually some scolding will come. He will tell and argument will come. There will be no damage to you, just a jerk. But if you hit a stationary vehicle, effect increases. But if the two opposite coming vehicle hits each other, tell me impact effect. Now tell me, where I wrote it? 90, where I wrote it? 90 this way, 80 this way. Where I wrote it now, first of all. Somewhere I wrote 90 speed, I write here. 90 speed this way, tell me. Impact effect now. Tell the impact effect. 170 is the effect. So, a vehicle already moving, a joint already moving. If this also moves same way, strain is lesser. If it is not moving, strain is little more. If it moves in the opposite direction, strain is more severe. Clear? Or roadside, a running vehicle hit from behind, medium. Usually fighting will come, verbal fighting. Hey, what is this? All those things. Injury will not be there. If it is 80 and 80, that's just touching only touching. See, injury will not be there. But roadside parked vehicle or tree, that is dangerous. Your full speed is causing trouble. Vehicle will what? Will get damaged. But opposite coming vehicle hit is worst case. Vehicle will become something like this. Have you seen in TV all? Vehicle become something this way. You will start wondering, what is that vehicle first of all? It will become like this. Clear? Therefore, remember, Final deformation. I write here now, answer now. Now see. Now we want everything in matrix form. If you want everything in matrix form, tell the answer. Deformation delta equal to, see, axial deformation for member ij in the bracket, increase in length is positive. Increase in length is positive. Why? Length is positive. Tension. That is delta ij equal to what? See here. uj into cos theta, vj into sin theta, vi into cos theta, uj into sin theta. I want I first. See, it is, see, cos theta, sin theta, again cos theta, sin theta, again cos theta and sin theta, but minus into what? Into ui, vi, uj, vj. See here, ui cos theta plus vi sin theta. Okay, sir. First uj will come. Into what? Into uj, vj, ui, vi. See, first j comes. See, uj cos theta, vj sin theta minus ui cos theta, ui sin theta. This looks very odd. Or you can do one thing. I want not ji, I want ij. To get ij, what you write? Minus cos theta, minus sin theta, cos theta, sin theta into correctly ui, vi, uj, vj. Correct? This is minus lambda, minus mu, lambda, mu. This is delta. Clear? I will put the final answer now. Or I will write the answer here now. Final answer is C. Therefore, final answer for any for member ij, axial deformation, that is what? Increase in length positive. That is called delta for ij equal to C, minus lambda minus mu matrix, then lambda mu into what? Into same order ui, vi, uj, vj. Okay, this is axial force. Then strain in the member, member ij, that is what? Tensile positive equal to strain equal to, tell what? Change in length by original length, that is called epsilon ij equal to 1 by L into same number minus lambda minus mu, lambda mu times what? ui, vi, uj and vj. Okay, then suppose you want stress in the member, that is sigma ij, tension positive equal to stress equal to strain into Young's modulus, here nothing, here 1 by L, here E by L into minus lambda minus mu, lambda mu into ui, vi, uj and vj. Clear? Now, for your FEM batch, for this question, each member change in length, strain and stress, I will write in a paper and send you. Actually, you can do it yourself only. Still, because you are in the group, I will take a paper, and for this member, I will give answer this one for all 3 members. Okay, done. General public, let them learn themselves only. There is a limit for giving here. For those who are in the FEM batch, in the group, I will send the answer for this one. Agreed? Now I will go to last part. Okay. And lastly, if I want force, multiply by area, or I will tell the last step here. This all I will write in a paper and send you. Why? Here YouTube, that much is not required. So the real or final requirement for design purpose is what? What I told you is the real requirement is axial force in member. Axial force in member IJ, tension positive is, that is called Pij equal to, remember formula, AE by L. Remember, if you don't write AE by L, it gives you axial deformation. If you divide by L, it will give you strain. If you use only E by L, it gives you stress. If you do AE by L, it gives you force. That force is the actual requirement for any designer. Yes or no? Clear? The force is the actual. Exam also, they won't ask the stress strain all. Even for exam, what they will ask? Analyze the given pin jointed frame and find forces in all the members. That is what they are asking. The strain all, they will not ask. But if they ask, those who are in the group have got examination, in the paper I am sending you. Those who are general public, learn it. Clear? Okay. Equal to, see, formula is, remember, first do one thing, minus lambda minus mu, then lambda mu times what? Ui, Vi, Uj and Vj is the answer. Now, come to the closing part of the question. Therefore, for our question, axial force P, see, for member CA equal to, see there, what is AE for the member? AE is 400 10 to the power 3. Divided by length is 6.7082. AE by L into, see correctly, what you do is, later write. Why? Sign change is there. Leave it. Third and fourth one, lambda mu. Where is lambda mu? Lambda is minus 0.8744. Mu is minus 0.4472. You write these two. Then, that is your lambda. See, this is your lambda. This is your mu. Come this side, change the sign. Minus becomes plus point, or you can make out there. Whatever is here, opposite. 0.8744, hey, come here, plus 0.4472 times, see here. See, member CA means, the jaga beksoppa, into, CA means what? CA means, member is CA, UC, VC, UA, VA. All the answer has got 10 to the power minus 3 outside. See there. UC. Where is UC? UC. Oh, here. UC. Minus 0.1528135. VC. VC barali. Minus 1.775603. Then UA is 0. VA is 0. Nodi. UA, VA both are 0. Tell me the answer in kilonewton with sign. Remember, tension positive. See now. 10 to the power 3 will cancel. Remember. See. Answer. Fast. You have to give me what answer I wrote here. For the member ACA, wherever you see, it is what? Minus 55.5 should come. It has to come minus 55.5. Otherwise, class will not continue. Answer. It has to come minus 55.5 because I know that member force is going to be 55.5 kilonewton compression. So 50.5 kilonewton. You write that is force in CA equal to 55.5 kilonewton. Negative came compression. Remember, if the force comes this way, it is compression. This, if doubt is there, you should attend, see my other classes. I told you, by suddenly it looks like tension. No, it is not that way. If the force comes and hits the joint, it is compression. If the force goes away from the joint, it is tension. Or it is first semester B concept. That in FEM I won't tell. Someone will tell, sir, it looks like tension. Oh, yes, looks like tension to you. For me, it looks like compression only. Answer first. It minus 55.5. Okay, done. Then next member. Force in member CB. AE for the member. 320 10 to the power 3. It is going to be cancelled later. Divided by length is 5 into what? Later, lambda mu. It is lambda mu. 0.8 and minus 0.6. Okay. Then here, come this side. Minus 0.8, come here. Plus 0.6 into, remember, CB. If it is CB, what do you require? CB, UC, VC, UB, VB. UC, illa is the answer. Minus 0.1528125. VC is here answer. Minus 1.775603. VB is 0. UB, it is UB. UB is not 0. UB is plus 0.57733. VB is 0. Answer passed. Answer. That is, I will tell the answer without sign. Therefore, I will tell force, real force in CB equal to, I want the answer in kilonewton. I know this also will come negative. That means compression. Answer. Answer first. You can see the answer in the board. Before explaining, I wrote the answer here. See, I wrote the answer there. I wrote the answer before I start anything. Check money. Fast check it. This much time to multiply. Over, only one more member left out. Class is over then. Tomorrow starting new part. Because why? Remaining questions I will do recorded. Because why? Now this much explained sufficient. You are wasting time. Minus 30.8. Only 30.6 is there. I told earlier 30.8. No, not possible. Oh, 30. Oh, I made wrong copying. 30.8. Correct. See, I also got 30.8 only. See here. While writing calculator problem. Minus 30.8. That means 30.8 kilonewton compression. And lastly, force in member BA equal to AE for BA 610 to the power 3 divided by 5 divided by 10 is the length into minus lambda minus mu. Amel baritini lambda mu is minus 10. Therefore here 10 into what all required? Into 10 to the power minus 3 times. Which one require? BA means what? BA means you require UB, VB, UC, VC. UB is here. Plus 0.57733. Other 3 are zeros. Fast answer. Only one number. Other numbers are 0 here. First, I already told you what is the answer should come. In my class, once I tell this is the answer to come, anywhere else, whatever method you solve, Same answer has to come. No problem has got exception in my class. If I tell in the beginning, this is that 30.6, I wrote wrong because when I saw the paper in the light, partially 8 looked like 6 to me, that's all. But I only got that answer. This time it will come plus. Don't tell. 34.64 plus 34.64 kilonewton. That means force in BA equal to 34.64 kilonewton tension. Therefore, if you want, you can put the sketch here, or forces are like this. See, compression of 55.5, all are in kilonewton. A, B, C. For 3 member, this is compression 30, this is tension of 34. Therefore, if it is a roof truss, this member should be designed to resist axial compression of 55.5 kilonewton. This member should have a tensile strength of at least 30.8, the bottom compressive strength of 30.8, the bottom chord member should have a tensile strength of at least 34.64. Everything clear means tell me, I will close. I may take one more class tomorrow for different varieties of questions, or I may not take. I will tell recorded class, I will give more questions for you. That way is help you, because see, or who knows, one more class tomorrow briefly I may take. And see, I will tell you some other cases. See, some member fixed to the wall, etc., or a suspended wire system. I may explain this briefly tomorrow, depends on my mood tomorrow. Or if I feel time is not there, I will, when I am free, I will keep on uploading one by one class. But if I give you, they will not be talking. If I record and upload, you can hear me every time. Clear? Only thing is no participation. Homework, what participation? Full clear. Is the concept of trusses today's class, because I did from beginning to end, useful? I thought first time coordinate system got interchanged. No problem. But suddenly I told, oh, what is this one? My second answer comes first comes second. Yesterday there was last class, there was an error for the numerical, later you corrected. Today there is absolutely no difficulty. So pin jointed frame. This is the principle how software will work, or how to solve by finite element method. Full clear means I will close the class. Tomorrow class 9:15 only. Full clear? I will close the class. So tomorrow I will decide one class I may take or may not take. Okay, thank you. See you tomorrow. So understand the principle. And that vehicle example, useful. That vehicle example, hitting from behind, hitting a standing vehicle, parked vehicle, or opposite vehicle. Is it fully clear? Concept, which is medium, which is difficult, which is worst case. That will tell you correctly. Okay, thank you.